Welcome to our discussion on subtraction of whole numbers. First thing to realize is that subtraction is really just addition in reverse. You're really just adding a negative, for one thing. Subtraction and addition are technically the same operation, just one is the inverse of the other. So obviously 3 plus 4 equals blank is the same thing as thinking of, well, we can go in the other direction and go 3 plus what is 7, right? This is still the same. And then, of course, when you subtract, you get 7 minus 3 is 4. So you can see that these things are strongly related. They're just inverses of each other. So if you know how to add, you know how to subtract. When you see things like differences, they're asking for subtraction. And here's a little bit trickier one, right? A 2-digit and a 2-digit. Well, just like with addition, the first thing we want to do is estimate it. So turn this into 50 minus 20, which gives us 30. And we know that our answer should be somewhere close to 30. So when we stick this in our calculators or do it by hand, and we get an answer of 2 or 240 or something like that, we go, uh-oh, it can't be right. But 24 is close enough to 30 that we think we probably didn't make any mistakes. Now, with some problems, it's necessary to rewrite the larger number before the problem can be solved because we have to do what's called carryover or borrowing. And that's whenever we're trying to subtract a number that is larger than the number we're trying to subtract it from. So in the first case here, if we're trying to take 128 from 426, we're basically, first we subtract the ones places, and we're trying to take 8 ones away from 6, and that's impossible. So what we do is we borrow. We take these two tens, and we go, okay, we're just going to leave one of them behind. We're going to borrow 10 over here, and we're now going to make this 16. So now we can do 16 minus 8 is 8. Great, everything's good. But now the problem is when we move to the second one, we're now trying to take a 2 away from the 1, and we got to borrow all over again. So we got to go over to the hundreds. We got to take one of these, make it a 3, bring the 1 over here. And now we have 11 tens, right? And then 11 minus 2 is 9. And we come over here, 3 minus 1 is 2, and we're all good. We didn't have to borrow that last time. And we get an answer of 298. But before we did any of that, we could have said this was 400 minus 100. Our answer should be close to 300. And of course, 298 is close. So don't forget that you always want to round so that you can double check that answer and make sure that you're at least in the right ballpark. You're not off by a factor of 10, let's say. Now, when we have these application problems, we need to recognize when to use subtraction. So you're looking for specific kind of terms, like the difference between things. How much remains? How much is left? How much is A greater than B? What was the increase from A to B? How much do you save? All these kinds of things are asking for a difference. And a difference means something minus something. So it's usually pretty easy to recognize subtraction when you're looking for verbiage that is talking about a difference of something. All right, let's look at a specific example. Suppose we need to finish the missing drawing L, right? We need this L measurement here. Along the top of the drawing, we know that it's 86 millimeters across. We also have the two lower bits of 32 and 25. So since we can assume these are all right angles, and the sum of these three should be the exact same sum, or just that same distance, then all we have to do is take 86, subtract these two pieces from it, and we get our resulting answer. So 86 minus the 32 minus the 25, we can estimate it as 90 minus 30 minus 30. So we should be around 30. When we actually do the math, we see that we can do it in steps, right? First we can take away the 32, get 54. Then from 54 we can take away the 25 and get 29. Or we could have taken these two numbers and added them together, right? And got 57, and then taken 57 from 86 and got there the same way. Our next example, talking about new cars, got to figure out the decision of whether or not to buy a hybrid version or not. So when you want to figure that out, you kind of have to figure out what's the difference in cost, what's the difference in savings for fuel, and so on and so forth. So we can use these figures to get a rough estimate for the 5-year total cost for each car. So all you got to do, take the sales price, add in our estimated 5-year fuel cost, insurance and fees, maintenance and repairs, and if we were able to sell it at the end of 5 years, what it would be worth. So we take all that stuff, and first we add up all the bad things, right? All the costs, money going out, how much we paid, how much paid for gas, pay for insurance, pay for repairs. Add all those together for both of the two cars. We can see they're very close. Last thing is to think about this kind of trade-in value. So we take those away from them, and we can see that the Camry has a higher cost, the hybrid that is, than the other one. But it's only marginally, right? And we have to remember that these are rough estimates because we really don't know, what our fuel costs are going to be, if they're going to go up or down drastically. Finally, we can find the difference between the two costs by simply just subtract them and see that it's $1,690 over 5 years based on initial price, blah, 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 blah. So the non-hybrid, technically, according to these numbers, would save the car buyer almost $1,700 over the first 5 years. But again, what happens if fuel prices skyrocket? Okay, that's all I got for you for this one.